Hello everyone, welcome to Intellify. I'm Garini SV. I'm here today to help you learn about the chapter number 1 number system of class 9 maths. Here in this video, we'll be looking at the topic real numbers and their decimal expansion. Come on, let's have fun with math. Okay, now we are going to see the decimal expansion of some few examples, namely 10 by 3, 7 by 8, 1 by 7. Here we are going to solve these by long division method. I know you are familiar with long division method. So now we are going to divide 10 by 3. So we are putting a quotient 3 here. So when we multiply 3 by 3, we get 9. So when we subtract the dividend by 9, we get the remainder as 1. Since the number remainder 1 is less than the divisor, we are putting a decimal point in the quotient. After putting the decimal point, you can add up a 0 here in the remainder. So now you are getting a number 10 which is greater than this divisor. So you can now divide this. If you put 3 here, you can divide it. 3 by 3 is 9. So again you are getting the remainder as 1. So in the frequent steps you will be getting the same remainder as 1 and the quotient is the same 3.333. It repeats. So the remainder here is 1, 1, 1. Okay, now let's look at another example, 1 by 7. When we divide 1 by 7, 1 is less than 7. So we are putting a decimal point in the quotient. So after putting that, you can add up a 0 in the dividend. Okay, when you divide 10 by 7, you have to place 1 under quotient. So 1 by 7 is 7. So 10 minus 7 is 3. Since 3 is less than 7, you can put a 0 here since you already placed a decimal point over here in the quotient. So you have to divide 30 by 7 here. Okay, now you're going to multiply 7 by 4 to get 28. When you subtract 30 minus 28, you're getting the remainder as 2. Okay, again this value 2 is less than 7, so you're putting a 0 here. Now you're putting 2 in the quotient to get the value 14 here. Again then you subtract these 20 minus 14, you're getting the remainder as 6. So this process goes on. So here we have 0.142857 as the quotient. See here you see after this step 50 minus 41 you are getting the remainder as 1. Since the value here is same as the dividend value 1, the quotient will be repeating after this 7. So you are getting the remainder the same value after some steps. So you are getting 3, 2, 6, 4, 5, 1. After that you are getting the same remainder 3, 2, 6, 4, 5, 1, etc. And this remainder will be repeated. Okay, now look at another one. You are going to divide 7 by 8. You already know 7 is less than 8. So you are putting a decimal point over here in the quotient and adding up a 0 in the dividend. You have to divide 70 by 8 here. So you are putting 8 in the quotient and when you multiply 8 by 8 you get 64. 70 minus 64 gives 6. This 6 is less than 8. So you are placing a 0 here. When you multiply 60 by divide 60 by 8, you are getting 7 here. So 7 into 8 is 56. You subtract 60 minus 56. You get the remainder as 4. 4 is less than 8. So you are placing a 0 here. You have to divide 40 by 8. So you are putting the quotient as 5 here. 5 into 8 is 40. When you subtract 40 and 40, you get the remainder as 0. Hence the division is closed now. So the quotient here you get is absolute, that is 0.875. You just have to pay attention to the reminders and see if you can find any pattern. Here in this first one you are getting the same reminder 1 1 1. In the second example we just saw after a few steps the reminder starts repeating itself. In the third example we just saw the reminder turns 0 after some steps. Let us conclude this. Now, the decimal expansion of rational numbers. Here we have two cases. If the remainder becomes 0, and the case 2 is if the remainder never becomes 0. In case 1, if the remainder becomes 0, we just saw the previous example that if we divide 7 by 8, we just saw the quotient is 0.875. Here the remainder turned 0 after some frequent steps. Here the decimal point terminated after some steps and it is not repeating. Here we have one more example. When we divide 1 by 2, we get the value as 0.5. Here the number is terminated and it doesn't repeat itself. So we can say if the remainder becomes 0, the value would be terminating. The case 2 is if the remainder never becomes 0. So when we divide 1 by 3, we get the value as 0.333. Here 3 repeats itself and it doesn't terminate at all. Here we have one more example, 1 by 7. We get 0.142857, 142857. Here these 6 digits 142857 gets repeated after some steps. So this value doesn't terminate. So this is non-terminating since it is repeating. Here 3 is repeating and 142857 here is repeating. So we can just say that it is non-terminating and recurring. Recurring is also called repeating. So we can say that the decimal expansion of a rational number only can be two choices. It can be either terminating or non-terminating recurring. Okay, we can just see that terminating numbers, decimal numbers are nothing but the number with a finite decimal part or for which the long division terminates after some finite steps. This is what terminating decimal number. Now look at non-terminating recurring decimals. They are nothing but the numbers with no finite decimal. It will not terminate. So for which the long division never comes to an end and the remainder starts repeating after some subsequent steps. This is called non-terminating recurring decimals. Let us see some examples to understand these concepts. Find the decimal expansion of 2 by 11. When you divide 2 by 11, 2 is less than 11. So you are placing a decimal point over here in the quotient and placing a 0 in the dividend. When you divide 20 by 11, you just have to place 1 in the quotient. When you multiply 11 by 1, you are getting the value as 11 here. So when you subtract 20 by 11, you are getting the remainder as 9. Since 9 is less than 11, you are placing a 0 here. Since you already placed a decimal point in the quotient. Now you have to divide 90 by 11. So you are placing 8 here. So 8 by 11 is 88. So 90 minus 88 is 2. So again you are getting the remainder the same 2 here. So here when you divide again 20 by 11, you are getting the same values. That is the quotient gets repeated 0.181818. So we can simply say that 18 can be replaced with a bar. These digits can be replaced with a bar. It means that the number gets repeated. Here you can see that the number is repeated and it is non-terminating. So non-terminating recurring. This is one type of that decimal number. Now look at the decimal expansion of minus 16 by 45. You just have to ignore this negative sign when you do the long division method. You can just include this minus sign in the final solution. So just you have to divide 16 by 45 in the first step. So 16 is less than 45. So you're placing a decimal point over here in the quotient. When you divide 6, you can also add 0 here, after which you placed a decimal point in the quotient. When you divide 160 by 45, you can place a quotient 3 here. So when you multiply 45 by 3, you're getting the value as 135. When you subtract this 160 and 135, you're getting the value as 25. Since this value 25 is less than 45, you're placing 5 here in the quotient. So when you multiply 45 by 5, you're getting 225. When you subtract these value, 250 minus 225, you're getting the remainder as 25 again. So since this value 25 is less than 45, you're placing a 0 here. This process goes on. So you can simply write that 0.3555. So here 5 gets repeated. So you can place a bar over here in only 5. Since 3 is not repeated, it doesn't have bar. Since 5 only repeated, it does have a bar here. So you can write 16 by 45 as 0.35 bar. Here you can see the number is not terminating and it repeated itself. So you can say it is non-terminating and recurring decimal. Till now, we saw two examples for non-terminating recurring. Next, you are going to look at the example for a terminating decimal form. Here we have a question, convert 35 by 16 into a decimal form. So when you divide 35 by 16, you get first 2 as a quotient. So when you multiply 16 into 2, you get 32. When you subtract this 35 minus 32, you get the remainder as 3. Since the remainder 3 is less than the value 16, you are placing a decimal point here in the quotient. After placing this decimal point, you can add a 0 here. So you have to now divide 30 by 16. So you are placing a quotient 1 here. When you multiply 16 by 1, you are getting 16. So when you subtract 30 minus 16, you are getting the remainder as 14. Since this 14 is less than 16, you are adding a 0 here since you already placed a decimal part here. So you have to now divide 140 by 16. So you are placing 8 here in the quotient. When you multiply 16 by 8, you are getting 128. When you subtract these, you are getting the remainder as 12. So now 12 is less than 16, so you can add a 0 here. Since you follow these steps, you get 0 after some steps. So that value gets terminated here and the value is not repeating. So you can say the quotient here is 35 by 16 gives you 2.1875, which is the terminating number because it terminates after some particular steps. Okay, now you are going to see the conversion of a terminating decimal number to the form P by Q. Till now you saw that how to convert a number of the form P by Q into a terminating or a non-terminating decimal number. Here we are going to see the conversion of that vice versa. So here we have generalized the steps for converting. If you are familiar with these concepts, you can convert any terminating decimal number into the form P by Q. You just don't have to worry about it. Just look at these general concepts first. Okay, look at the first step. You just have to obtain the rational number which is given to you, which is given in the question already. You have to assign the value x to that rational number. Let's go to step 2. You just have to identify the number of digits that is after the decimal part. After finding the number of digits after the decimal part, you just have to go to step 3. You have to remove the decimal point from the numerator. In the denominator, you just have to write 1 and add as many zeros on the right side of 1. The number of zeros you put on the right side of 1 should be equal to the number of digits which you calculated in step 2. After writing this, you just have to find a common divisor of the numerator and the denominator. Now you have to express the rational number to the lowest term. This is found by dividing its numerator and denominator by the common divisor. I hope you understand this general concept. Let us look at the example of this. Given that 3.142678 is a rational number, you just have to show this as the rational number. In other words, rational number is nothing but it is of the form p by q, where p and q are integers and q not equals 0. The solution here is, let us follow the steps which we are given in the previous slide. The first step is assign the value of x to the given rational number 3.142678. Okay, the step 2 is you just have to examine the number of digits after the decimal point. Here you can see there are 6 digits after the decimal point. Then after finding this, you just have to go to step 3. Remove the decimal point in the numerator and write 1 in the denominator. You just have to add number of zeros as you calculated in step 2. There are 6 numbers after the decimal point, so you are adding 6 zeros in the denominator. This is so simple, right? This can be written in the form of p by q, so it is a rational number. Next, the conversion of a recurring decimal number to the form p by q. In the previous example, we just saw how to convert a terminating decimal number to the form p by q. Here we are seeing the conversion of recurring decimal number to the form p by q. So let us see how. The first step is the same as the previous one. You have to obtain the given decimal and write it equal to x. The second step is you just have to carefully identify the repeating decimal to find the repeating digits, which we already did in the previous example. Okay, in the step 3, you just have to place the repeating digits to the left of the decimal point. After the step 3, you just have to place the repeating digits to the right of the decimal point. Here in the step 3 and step 4, you will be getting two equations. In the step 5, you just have to subtract the left sides of the two equations and right sides of the two equations. As we subtract both left and right sides of the two equations, you just have to make sure that the differences of both the sides must be positive. I hope you are clear with this general concept. Let us look at an example. Now you are given the question that you have to convert 0.777 etc. into rational fraction. The first step is so simple. You just have to simply assign the value of x is equal to the given question. So x is equal to 0.777 etc. After this, you just have to find the repeating digit in this x value. Here 7 is the only digit which gets repeated. So after finding the repeating digit, you have to go to step 3. You have to place the repeating digit, that is 7, here to the left of the decimal point. In order to do that, you just simply have to move the decimal point one place to the right. That is, this can be found by multiplying the given number by 10. So you can multiply the equation number 1 by 10. So 10x, that is equal to 7.777 etc. The next one, step 4, is after the step 3, you have to place the repeating digit to the right of the decimal point. In this case, if we place the repeating digit to the right of the decimal point, again we get the original number. That is, we have the same value as x. So we are writing it as x is equal to 0.777 etc. In the step 3, we had one equation, and in the step 4, we have one equation. We have to solve these two equations. The fourth step, we had x is equal to 0.777 etc. and in the third step we had 10x is equal to 7.777 etc. You have to subtract the left and right hand sides of the two equations. 10x minus x gives you 9x and 7.777 minus 0.777 etc. gives you 7.0. So here you get 9x, that is equal to 7.0. So when you solve for x, x is equal to 7 by 9. So x equal to 7 by 9 is the required rational number. So just we represented 0.777 etc. into the form P by Q, that is 7 by 9. The next one, in the previous example we just saw the conversion of a pure recurring decimal number. Now we are going to see a mixed recurring decimal number. Okay, let us see how. Here also we have the general concept. The first one is the same as the previous one. You just have to assign the value of x is equal to the given mixed recurring decimal. After the step 1, you just have to determine the number of digits that do not have bar on them after the decimal point. Let us assume that there are n digits without bar, that is after the decimal point. After finding all this in step 2, you just have to go to step 3, that is multiply both sides of x by the 10 power n value, so that only the repeating decimal is on the right side of the decimal point. Then go to step 4. We just saw the method of converting pure recurring decimal into the form P by Q in the previous one. So after completing the steps 3, you can also use the method which we used already and obtain the value of x. This is so simple, right? Let us see with an example. Convert 0.2353535 etc. Here only 35 gets repeated and not 2. So this is called mixed recurring decimal into the rational fraction. So the first step is the usual one, x is equal to the given mixed recurring decimal 0.235. Here 35 only has bar since 35 gets repeated. After this you have to examine which number after the decimal point doesn't have a bar. Here 2 does not repeat, but the block of numbers, that is 35, gets repeated. Okay, after you found this, you have to go to step 3, that is since here we have 3 numbers after the decimal point. Since 2 digits are only repeating, we just multiply x by 100. Since 2 digits are repeating, we multiply x by 100. It depends upon the number which repeated. Okay, now 100x is equal to, we are multiplying this step equation number 1 by 100. So 100x will give you, that is equal to 23.53535 etc. So when you simplify this, you get 100x, that is equal to 23.3 plus 0.23535 etc. This value is same as x. So you are writing the value here 23.3 plus x. So you are getting 100x is equal to 23.3 plus x. You get this x value to the left hand side. So 100x minus x will give you 99x, that is equal to 23.3. You can also write this value 23.3 as 233 by 10. So x is equal to 233 by 10 into 1 by 99. So when we multiply this, we get x is equal to 233 by 990. This is the required rational number here. Yay! We have converted this number into the required rational number, that is of the form P by Q. So far we have learnt the terminating and non-terminating recurring numbers. Here we have a new concept, that is non-terminating and non-recurring decimals. What is it? Let us see. Non-recurring numbers are those which do not repeat the values after the decimal point. The numbers which doesn't end, that is non-terminating, and the values does not repeat, so it is non-recurring. So we can simply say that the number which do not repeat the values after the decimal point is called non-terminating and non-recurring decimal numbers. Here we have few examples of those. The root 2 value is equal to 1.414213 etc. It goes on. It never ends. So it is non-terminating and the number is not repeated. So it is non-recurring. Let us see another example here. Root 3, 1.732. In all these 4 examples, you could see that the number never ends after the decimal point. So we can simply say that it is non-terminating. And you just look at the numbers and see whether any digit is repeated. No, isn't it? So it is non-recurring. So we can say that these are some of the examples of non-terminating and non-recurring decimal numbers. So the decimal expansion of an irrational number is non-terminating and non-recurring. So you could say that a number whose decimal expansion is non-terminating and non-recurring is found to be irrational. I guess you're all familiar with the concepts. Now we see the summary chart. We just saw the decimal expansion of the real numbers. This can be either terminating or non-terminating. If it is terminating, it is known to be a rational number. If it is non-terminating, there are two conditions. One is either it is repeating or it is non-repeating. If it is repeating, it is a rational number. If it is non-repeating, that is non-terminating and non-repeating, it is an irrational number. I hope you understood the concepts well. Thank you for watching.